Okay, we're going to go live.
Okay.
I need to move you. Yes, yes, yes. Okay. All right. We are, in theory, we're live. We're live. People are telling us that we're live.
Okay. Okay, cool.
So I was mentioning this, and fellow West Coasters know exactly what I'm about to say, which is that I think last week I was like, yeah, it's been cool and fine, and it's been wet. It's been a really nice spring so far. Yeah, so far, and I'm like, we've avoided those heat waves. Well, the heat wave hit us.
Nope.
So today it starts. Normally in here, like in middle of June, late June, like a nice day is 25 degrees Celsius. Average, we're 20 degrees Celsius. Like it's cool. And it doesn't really get hot until July, August. So today the temperature is supposed to hit 34. And on Monday it's supposed to hit 39, which is, for the Americans there, that's 103 Fahrenheit. And we never go beyond 29. Like 30 degrees is a hot day for us here on the west coast of Canada. So for us to hit 39, it's just going to be crazy. Nobody has air conditioning here.
Oh, that I hadn't thought through. You don't even have window units you can throw in.
Nope. So it's actually kind of dangerous. It's sort of like those heat waves that they were seeing in Europe in the last couple of years. So we actually do have we have one of those portable air conditioners. So that was one of Carla's first purchases when she showed up here. It's pretty funny because, we all it doesn't even occur to us to buy an air conditioner. And so we'll see what happens. We may end up being huddled in the bedroom with the air conditioner running while we make it through.
Yeah, we've been periodically doing that.
Yeah, we've got about a week of this high temperature. It's a heat dome.
Yeah, it sucks.
Yeah.
All right, I'm just going to have to go with the big headphones today.
Yeah, it's fine.
Yep.
Yeah.
Okay. My hair wanted to eat that set, and it didn't want to connect to the computer, so.
Ready?
All right. Let me check that it's recording with the correct microphone, or I will make Richard sad, and I don't like to make Richard sad. And I'll need to turn my AC off because I have a window unit right next to me. I am literally sitting
we can hear
half a meter in front of my AC unit. Okay. I am pressing record.
I am also pressing record. Okay.
All right.
You ready?
This is looking good. Yep.
All right. Astronomy Cast, episode 611, Confirming Intelligent Alien Life. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. It is thunderstormy here, but so far the tornadoes have stayed on the other side of the river, which I call a win, especially when I look at your weather.
Yeah. We were talking about this before the show, that we are going to be experiencing extreme heat here on the west coast of Canada. Normally in June, temperatures are 20 to 25. It's cool. It's really nice. It's perfect weather usually. But yeah, we're supposed to hit 34 degrees today and 39 by Monday, which is like what you might experience in Phoenix. It's crazy. Yeah. It's going to be outrageous, and nobody has air conditioning in this part of the world. So it's going to be an interesting couple of days for sure. Yeah, we're going to be huddled up in the one room that we have an air conditioning unit in, or huddled down in the basement. We'll see what happens.
And since this may be the new normal, I recommend getting window units.
Yeah. When we build our new place, we're actually going to get a passive heating cooling system, heat pump. So, yeah. There's
Yep.
new technology. Our house is so old right now, but our new place will have newer technology. All right, so last week we talked about what it's going to take to confirm basic biological life across the solar system and the Milky Way. This week, we'll discuss what it's going to take to detect intelligent life out there in space. And we will do that. But first, let's have a break. And we're back. So it's funny. I had this conversation with Dr. Jason Wright, who's one of my favorite exoplanetary researchers. And we were sort of talking about this shift from the NASA and the rest of the scientific community that's starting to be interested in adopting and funding research that's searching for intelligent life. And he was like, we're okay for searching for dumb life, but why aren't we okay for searching for smart life? But there is a bit of a sea change that's starting to happen. So tell me about the search for intelligent life so far.
Well, so far it has primarily taken a very limited number of forms. There is, of course, the very well advertised by the movie Contact method of using radio telescopes to look for systematically altering radio signals that are altering in a way that indicates there's an intelligence behind that is trying to send us information. Beyond looking for these radio signals that have, well, an actual signal in them, we have done things like look for the infrared excess of Dyson spheres and other megastructures that are out there in catalog data. So this is a matter of you can take data that already exists, look through it and see, hey, is there anything out there consistent with megastructures? So far, I haven't found anything that way either.
So let's start with this idea of searching for radio signals. Why are radio signals like the best thing to search for? Because that's where we started.
Well, it's multi-part. First of all, the radio signals most of the time aren't going to get drowned out from a star's light the same way an optical signal would be. Folks have talked about using lasers to try and signal aliens out there who might be able to see us transiting our sun, and trying to basically be a beacon of light literally across the cosmos saying, here be life. Others have said, please don't do that. We don't want to be killed. But there is a chance that there are braver souls out there in whatever shape they may take that have also realized that light with radio wavelengths can be used to send information that won't get drowned out by the stars, and are trying to communicate this way.
And also, I mean, a radio signal is unambiguous. There are frequencies that you can put into a radio signal that cannot be produced by nature.
Yes. And that's the importance of looking at how it's modulated. We're used to carrier signals, side signals, all these different things that are taken advantage of by television broadcasts, by radio stations, to do things, especially now with digital television, as complex as putting different languages on slightly different versions of the same signal. And by being able to modulate signals in ways that clearly show mathematical intent, nature doesn't generally do that. And so we're out there looking for those prime numbers and whatever base they might be in.
So, I mean, there's like two parts to it. There's that there can be radio signals in parts of the spectrum that there is no natural way to produce it, but then there also can be a signal in the radio wave that is clearly provided by some intelligent civilization, as you say, prime numbers, what have you.
And this is where it also starts to get down to if there is something that is produced in a wavelength where we don't think there should be signals, there's going to be a whole lot of people going, No, nature just figured out how to do something we don't understand.
Right. Yeah.
So you really need those prime numbers to get folks to believe it.
Yeah. Yeah. But I've definitely heard that there are some signals, like if we see some, even like a combination of signals all at the same time,
Yes.
then you know for certain there's nothing out there that can produce this that isn't a radio transmitter. So then, I mean, that sounds like the perfect system. What's the downside of radio waves?
Well, to create something capable of traveling through space and still having enough signal by the time it gets to us requires purpose. Yes, the Earth has been leaking television and radio signals for more than a century, but while those signals are out there, they're going to get lost in the background of radio galaxies, of pulsars, of everything else. And they're also fighting against each other, where all those FM stations, they're all going to get muddled together. And if my car can't easily detect something in St. Louis, which is like a half hour's drive away,
Right. Yeah.
I need to worry.
Right. And so when you say intentional, essentially the alien civilizations will need to see Earth and go, here's a message for you, Earth. Point their giant radio transmitter specifically at the Earth and release the light. And if if someone over on Alpha Centauri nearby, they're not going to see this signal. So you've got to get this alien civilization that has chosen us specifically to receive this message.
And this actually isn't that ludicrous an idea. There are some 2,000 worlds, or rather 2,000 stars that we believe have worlds, that from where they're positioned over the coming years and centuries, they'll be able to see the Earth passing in front of the sun's disk of light. And if we know where they are, and we wait until we're transiting the sun so they know where we are, and we shoot a signal their way, hopefully they'll be listening. And we are preferentially looking for signals from transiting planets that we hope know, hey, maybe people out in these directions know that we're here.
And of course, a lot of people are totally freaked out about this possibility of us transmitting to some other alien civilization. And hopefully, by the end of this conversation, you will realize that horse is already out of the stable. The aliens know we're here. But we'll talk about that in a second. But first, it's time for a break. And we're back. Okay, so that's one kind of signal. Aliens point their big radio transmitter at Earth and let us know they're here. Now, you mentioned briefly laser light. What are some other ways that aliens could target us directly? Because we'll get into them leaking their existence unintentionally. But first, I'd like to, they're trying to reach out to us and let us know that we're not alone in the universe. What a kind thing for them to do. How else could they do it?
So there's things like you can develop masers that you then purposefully modulate. We see masers in a variety. This is a microwave laser. We see masers in a variety of planetary atmospheres and clouds of dust and gas. Well, take one and figure out how to modulate it, which is something beyond what we can easily do at the level that it's going to shine bright enough to see across the galaxy right now. But this is the kind of thing we can do on the small scale. And it's just a matter of technology and energy to do it on the big scale. So let's look at those naturally occurring microwave lasers and see if any of them are, dropping a beat. Mm-hmm. And that could be a definitive signal. Then purposefully trying to get our attention, lasers are another way. Now, the question is, how do you put together a signal that clearly isn't a star? Well, you can do that with a laser because it's a single color of light, but then also make it bright enough that it can be seen at that distance. Again, you're looking at massive energy consumption being required. So anyone that we're going to be able to see that is purposefully trying to signal us is going to be more advanced than us. And that's a bit intimidating.
Back to this idea of the transit method, one idea that I think I really like as well that would require more startup energy, but then would be easier is to launch, say, triangular shaped satellites around the star, because these would give off a very bizarre signal as they transit in front of the star. From our perspective, it would be completely unnatural to see these.
And the reason that this works is if you have some odd shaped structure, and I'm trying to find something round. Duct tape. If you have an odd shaped structure, as it passes in front of something else, the amount of light that it blocks is going to change in a very different way than if you have a round structure passing in front of the star. And so we can actually tell the shape of whatever it is that's blocking out starlight by the way the light that we receive changes. And a triangle is kind of the most simplistic structure that you can get. And a good old equilateral, especially one that you maybe vary the orientation with every orbit, would be a great way to say, hey, we're here. Look at us doing weird stuff with our star.
Right.
And it could be fun.
Yeah, and so they could launch, say, some giant triangular shaped solar sail and have it pass in front of the star. It's one big launch. Yeah, it's tough to do that. But once that's done, then they don't have to continue sending messages. It just keeps passing in front of its star every few years and showing the universe that they're there. What about technologies that we just are starting to understand but might prove very effective, like neutrinos or maybe gravitational waves?
And this is something where we don't actually know if it's possible to communicate this way. Now, if you happen to have a pair of entangled particles that are generated, you can, we believe, separate them by light years and still see the flip of state in one in the other. But you need to start out with one of the particles and then send the other way off. So you can't use entangled particles to talk with aliens unless it's prearranged.
Right. Yeah. There's no benefit to using entanglement to communicate. But like neutrinos, I mean, we have a worldwide network of neutrino detectors poised to catch the next nearby supernova.
Yes. And here we can imagine we know how to create neutrinos, just not in massive amounts. We can create them. Heck, every nuclear reactor on the planet Earth is creating neutrinos. If we could figure out how to much more massively generate neutrinos without destroying our planet, that's a key, and send them in a unified direction and be able to turn it on and off that signal so it's not mistaken for a supernova, it may be possible to confuse people who are also doing neutrino science enough to figure out, well, that doesn't look natural. Now, neutrinos, because they are so hard to detect, it's going to be hard to create enough signal that we can unambiguously say that's intelligence.
Right.
But then gravitational waves is something else where it would take such massive energy that to create something that unambiguously says that is intelligence, you have to wonder just how advanced is that civilization? Are they building their own method to move stellar mass black holes around and fling them together just to communicate?
Yeah, exactly. They collide two black holes together to say hi.
Right, exactly. And that feels like an awful waste of energy, but we have to be aware that the way we think, the way we imagine, the way we perceive time may not be the same as whatever else is out there. So we have to be prepared for weirdo signals in our neutrinos, for strange signals in our black holes. I mean, imagine that if instead of getting the characteristic black hole chirp, we got a musical melody. That would completely confuse the bejesus out of everyone doing black hole science.
Yeah, that would be crazy. All right, so we've talked about some active methods that aliens could be reaching out and trying to communicate. In a second, we're going to talk about the ways that aliens could let us know they exist by accident. And of course, think about that we could be doing the same. But anyway, we'll talk about that in a second, but it's time for another break. And we're back. All right, so let's talk about ways that we could sneakily detect aliens, intelligent civilizations out there in the universe.
Pollution. This is one of my favorites. I actually have it. I don't know if he remembers this. I made a bet with Seth Shostak a number of years ago that while we were alive, life, or at least a civilization by its carnage, would be discovered through its atmospheric pollution. So there's combinations of molecules in our environment that just aren't naturally occurring. You don't get combustion engines. You don't get the nucleotide distributions in terms of like all the stuff that was created during atomic blasts. You don't get just free oxygen with all this other stuff going on unless there is life to produce the oxygen and intelligence to pollute it.
Right, the chlorofluorocarbons as the aliens wreck their ozone layer. So,
exactly.
Yeah.
Exactly.
So we could detect the pollution, and I mean it's probably beyond the capability of any telescope currently, but things like James Webb and the next generation telescopes after that should just barely be able to sense that kind of thing.
And so there's the potential that one refuses to launch telescope that should have gone up in 2007. Thank you very much. One very belated telescope away from finding civilizations.
Right.
And then science fiction writers have pointed out some really amazing things. Imagine if we decide with our tidally locked moon that we want to put communication stations up on the moon that are strong enough to send a signal so that everyone who can see the moon can hear that radio station, watch that television news. Now, that's a high energy thing to do. It's kind of not effective, probably never going to happen. But you can kind of imagine a public art project going this way. Well, as that moon orbits its world, we would see that radio signal turning on and off with its orbit.
Right.
And so here is the way to get a massive radio signal that behaves in strange ways and says, there's life doing something weird right over there.
Mm-hmm. Now, and that's different than sending a specific beamed signal towards the Earth. This would be more like the leaked electromagnetic radiation, the leaked radio waves coming from the planet and its moon, and that's way trickier to detect, but not impossible.
And also makes excellent science fiction. The Sparrow by Mary Norris Russell has this as part of its premise.
Well, I mean, a telescope that's in the works right now, the Square Kilometer Array, in theory, can detect and I forget, I'm trying to remember the exact numbers, but something like the air traffic control systems of planet Earth to a distance of about 100 light years. And that's leaked radio transmission, so not directly beamed out, but you literally will hear with the Square Kilometer Array alien airplanes landing 100 light years away, which is crazy.
That is a bit disturbing.
Right. So imagine a super square kilometer, a 10 square kilometer array, a 100 square kilometer array, a space-based square kilometer array.
Yeah.
Like, in theory, we should be able to get to this.
Turn that giant triangle into a radio telescope.
Yeah. So then imagine, what are some other things that we do as a civilization that could theoretically be detected by other civilizations and vice versa?
Well, we light things up. Our light pollution actually is something that could be seen. There's been some really cool studies done during lunar eclipses where they've looked at variations in the Earth shine coming off the moon, and they've been able to see that there's light coming off the Earth that is affecting what we see on the moon.
From our light pollution.
So light pollution, our light pollution can
That's amazing.
be seen from space. So there's light pollution as an option. And then just like building stuff in places that weren't that way to begin with. So take an asteroid in the cold darkness of space, hanging out, doing its cold, dark space kind of thing, and start putting civilizations from it on it, a la The Expanse. Well, that's going to heat that asteroid up to a temperature it wasn't meant to be. It's going to add lights in specific wavelengths that don't really make sense for a black body. And that combination of excess heat and LED lights, fluorescent lights, whatever kind of light that you're using, that says there's something not natural there.
I can imagine this future advanced civilization, which has colonized their entire solar system. They've got cities on their other terrestrial planets. They've got bases and stuff on all of the different asteroids. You've now got a totally different electromagnetic signature, different light curve coming from this star and its planets than you would if it was just a regular star and empty dead planets.
Well, and to use a won't ever hopefully actually exist example, imagine the Star Wars planet Coruscant with all of its lights, all of its buildings, and now make all of them like compressed sodium bulbs. Suddenly you have this weird atomic spectral feature due to using the same kind of light bulb everywhere. And we can imagine a similar, everyone uses blue LEDs, everyone, by using a consistent form of lighting, because it's cheap and efficient, you specifically screw up the light coming from your solar system in a really cool way.
And you sort of mentioned this earlier on in the episode, but if you take this to its logical extreme and you actually enclose the star in some Dyson swarm, what kind of a signature does that give off?
It creates an infrared peak. And so you have to be careful because there could be a debris disk, and it's not easy to separate a Dyson swarm from a debris disk. But different composition things radiate heat in different ways. We can actually, to a certain degree, tell what is the composition of an asteroid by how it re-radiates light. And if we look close and we see that there's an infrared excess that is consistent with it being a big old metal object out there. It could be a big old metal object out there. Now add some LED lights and it's a done deal.
Right. Yeah. So the LED sphere is surrounded by LED lights blinking out there, and you've got a pretty interesting signature. And you can take this idea to the logical extreme, this idea of some alien civilization that has enclosed all of the stars in their entire galaxy in Dyson spheres. Now you've got a galaxy that looks weird.
Yeah. And that starts to become, how do you initially differentiate that from just dark matter galaxy? And so you have to really just sit there with a telescope and expose and expose and expose. And it's kind of crazy to think. We have found at least one galaxy that, no matter how we look, appears to have no dark matter. And if we find a galaxy out there that appears to have no luminous matter, now we need to figure out if aliens just hit it.
Right.
Just hit it.
Just hid the entire galaxy.
It's a thing.
Yeah. So which of all of these methods do you think is going to be the one that pays off first?
I honestly think that the first thing that we're going to find is going to be a polluted atmosphere, because I suspect pretty much every form of life that occupies land on its way to civilizing is going through and now we burn stuff phase.
Right. Yeah. Now we drive places phase.
Yeah. Well, even if they don't drive places, they're probably going to burn stuff.
Yep. And
that'll show up. And then I keep thinking that a ring world out there with its IR excess superimposed on a star, that wouldn't be that hard to find. And while we haven't found one yet, I keep hoping. I keep hoping.
It is kind of amazing when you think of how quickly our telescopes are getting bigger and bigger. With the Event Horizon Telescope, we have a telescope the size of planet Earth. There are plans in the works to maybe make that the size of the solar system. There are future space telescopes in the works, like LUVOIR and HabEx and stuff, that are going to be dramatically bigger and more powerful than even James Webb. And so continue that technology on for hundreds of years. And it just seems impossible that we won't have the capability to detect intelligent life in a pretty vast chunk of the Milky Way. And so then if we still haven't seen any life and we have the ability to scan a quarter of the Milky Way's volume, what do you think that means?
Well, so it could either mean that the universe is mostly empty or is mostly filled with people who take a look at how they live in a way that is closer to the thinking of the indigenous peoples here of North America, where instead of seeing themselves as having a right to the land, a right to the world, a right to the solar system to use and colonize as they will, that if they instead see it as they have an obligation to the land, they have an obligation to the animals to be there as stewards and to protect. If that different ideal of being a steward of the landscape is the dominant one in the universe, it's going to be a whole lot harder to find alien civilizations. And that is something for the philosophers and the writers to contemplate.
Or they're all just jacked into the Matrix and they don't bother
There's that
going out into the world anymore. But yeah, super interesting. Yeah. All right. Thank you, Pamela.
Thank you.
All right. Did you have some names for us this week?
I will, but I need to find the correct window. I was not planning to record from upstairs, folks. I was attacked by flies. So there was a last minute, oh my goodness, must go upstairs. This is horrible. There are fly pictures on my Twitter feed should you wish to go see the flies that attacked me.
They must be pretty badass flies that you were forced to flee from your recording studio.
Well, they kept trying to land on me. It's very hard to record when the flies are trying to land on you.
Yeah.
So I'm probably going to go downstairs with an open bottle of beer and a camera with a macro lens and see what I can do and wish I had Carla's skills.
Yeah. Names.
All right. So, sorry, I added editing to you, Rich.
Yeah, that's all Rich's problem now.
Yeah. So we are, as always, brought to you by you. And as a reminder, when we go on summer hiatus, it's so that we can improve what we do, take some time off. And when we come back in the fall, it is my hope that we're going to be able to bring you live media, videos, images while we talk here on Astronomy Cast. We can only make this happen thanks to your year-round support over on patreon.com/astronomycast. This week, I would like to thank Wayne Johnson, Iggy Himmick, Jeff McDonald, Reuben McCarthy, Philip Grand, The Mysterious Mark, Renda, Jim McGeehan, Chris Wilwright, Bob the Cat, Kathleen Matson, Mark Phillips, Leah Harborn, Father Prax, Scott Bieber, GeForce 184, Ronald McCoy, John, Aaron Tannenbaum, J. Alex Alexanderson, Brian Kilby, Tim Garish, Michael Cullen, Roland Warmerdam, Brent Nearnap, Marco Israsi, Jeremy Kerwin, Mark Stephen Raznak, Omar Del Riviera, Dustin Ralph, Claudia Mastriani, Aaron Segrev, Zeber Lark, Froda Tannenbaum, Paul Hayden, Arthur Letts Hall, Joe Wilkinson, Matthew Horstham, Justin Proctor, Samansky, and Alex Rain. Thank you all so much for being here, supporting us, and allowing us to do what we do.
Thanks, everyone, and we'll see you next week.
Goodbye. And now they saved.
Then they saved.
All right. Cool. I'm turning my AC back on.
Do it. Okay.
Stella is sitting on the ottoman behind me, looking out the bird feeder, wishing for birds to land in the bird feeder.
Is Stella a bird chaser?
She kills groundhogs. I'm not happy about this. So far, she hasn't caught any birds, but she has chased them.
That's fun.
Luckily, she can't fly.
Yeah.
I'm not fond of my killer dog.
Whoops.
What's wrong?
Oh, it's just trying to export. I gotta save. I'll be okay. Don't worry about me. All right, go ahead and put any questions you got. There was actually a lot of good questions, so we'll have lots of good stuff. We won't have to just rant about something.
Looking to see. Broken Symmetry made a great comment. Aliens may judge us by our recycling habits. Yes, this is true.
Yeah, I mean, it's like, I mean, you know, you put it in the state of like them learning how to be better conservators of the land and taking responsibility and so on. But it's really also a matter of self-preservation. Like you either figure out how to not overuse the resources that you have available to you, or you die.
Well, there's also though that Dyson sphere model of, and now I'm just going to tear everything apart and put it back together the way I want it, which kind of is you destroy everything in the name of building your own environment from scratch.
Right. In theory, at that point, you understand how to build it. What's important for an environment. Because if you are going to wreck the natural planet and build your own artificial one, I mean, sure, in theory, you could have more biodiversity. You could have, a much better situation for life. But if you get it wrong, then you've just got a bunch of, crappy, rundown.
It's Snowpiercer.
Yeah, space metal floating around. All right, let's see. Hal McKinney asks, how would we know neutrinos associated with a supernova weren't initially propelled near Earth by high-energy photons from a supernova? Do supernovae propel photons? No.
So propel is the wrong word because light goes at the speed of light and defines time around it. Neutrinos go nearly the speed of light, but they have mass, so they do not actually go the speed of light. And neutrinos can have different velocities. You could have a neutrino hanging out in a petri dish if you knew how to do that. Not sure you could detect it, but you could do it. So in theory, you could pulse neutrinos in a way that if someone had a big enough detector, they could sense the pulses of neutrinos.
Right. Unc Willie is asking, what about the idea of using the sun as an amplifier?
So you can use the sun as an amplifier with gravitational lensing. So this is like shining a flashlight into the eyepiece of your telescope and using it as a spotlight. You can do it. It requires doing the math first to figure out where you need to be and to figure out where the light's going to get focused. And so you better know where you're aiming, I guess.
So could you fire a signal at the sun, and know that some distant observer is going to get a collimated signal thanks to the gravitational lensing? Or do you have to, because I know, like, for example, if you want to use the sun as a telescope, you have to go out to about 1,000 astronomical units before you can use the sun as a telescope. But is it the same thing that if you want to aim a beam at an exoplanet on the far side of the sun, you have to go to 1,000 AUs and then start transmitting at the sun and then let the signal wrap around the sun?
No, it's more complicated than that. So it's more complicated because with the 1,000 AUs, that is focusing light that is coming in collimated. All the light beams are parallel. And so it's basically you're focusing light that's coming in from infinity. This is more like the case of, so that's the sunlight through a magnifying glass to kill an ant.
Mm-hmm.
Now, if you want to, and don't do this, folks, if you want to instead take a flashlight, shine it through your magnifying glass and create a pinprick of light, you're going to have to fuss more with trying to figure out where to put that flashlight, because now you're moving both focal points, both the origin and the destination. So since we wouldn't be at infinity, and we can't create readily a giant collimated light beam from within our solar system, we're going to have to do the maths. And I've never tried to do these maths to figure out where the two focal points are. It's just an optics problem. It's an ugly one.
Arjun asks, could anyone have seen Hiroshima, like the radiation? Would we be able to see nuclear
I saw discussions.
blasts?
Yeah, I saw discussions like that over on Twitch as well, where people are talking about how nuclear bombs are basically little tiny supernovae. Mm-hmm. So theoretically, if you were sensitive enough, you would have noticed an excess of neutrinos coming from our solar system, and also the excess of weird extra high energy particles during the 40s through 70s. I'm trying to remember when the test ban treaty went into place.
Okay.
And so that probably would have flagged us as weird if they had the right technology. You can almost imagine, and here this gets back to ideas from science fiction, a civilization that uses nuclear bombs to fire their rockets. Those are going to give away their system in a completely different way, because gamma, X-ray, and neutrinos.
Arjun also asks, could we detect non-natural surfaces on other planets like concrete? Because, I mean, I know that here in our cities, we have these weird heat islands around cities. Go back to your Coruscant idea.
So cement is just a mixture of minerals, and I'm not sure if it's different enough from what you'd get from a terrestrial world that you'd be able to tell. I just don't know if its black body spectrum is unique enough. I feel like it wouldn't be. Now, if you covered over a planet in a atom thick layer of gold, that might show up as specific.
Nancy Graziano asks, how can we claim nature doesn't create things in a methodical way when the Fibonacci sequence is found basically everywhere throughout nature here on Earth?
So there are certain mathematics that crop up over and over. We don't fully understand why. There's a cool book called The Golden Ratio by Mario Livio that looks into this. And it appears that the way waves travel through space, it appears that the most stable way for plants to grow certain things is in the ratio that comes out as the golden ratio in the Fibonacci series, the 1, 1, 2, 3, 5 series of how things add together and build. And this is why we don't go looking for the Fibonacci series. We go looking for prime numbers. Prime numbers are numbers that can't be divided into two other integers. 7 is one, for example. It's these prime numbers in whatever base they may be in that don't appear to be naturally occurring.
Swedmiro, the surplus raw data from observatories and experiments of different kinds, is that available for happy amateurs to download and play around with? Just asking for a friend.
A lot of the data is go forth and dig in, have fun. I believe the LIGO data, they actually have a Twitter feed that now says whenever something happens.
Yep.
Planetary data, most of it from the world goes into NASA's planetary data systems, which are a variety of different service portals. There is the Canadian Astronomical Data Center, which holds a ton of space data. There's the Hubble Space Telescope.
European Southern Observatory has a huge collection of data.
One of the easiest ways to get this data is I believe it's the NASA Virtual Observatory. is a easy to use portal to astronomical data, but it doesn't contain planetary data, at least not on purpose.
Right. Generally, what I'll do is like search for raw. So like do a search for say Cassini images, raw Cassini images, or raw ESO data, things like that, and usually you'll find it. So
and the good folks at Unmanned Spaceflight will help.
Yeah, so it's it's amazing. And if you do search for, say, raw Cassini images, you'll go to the full archive of every picture that was ever taken by any of Cassini's instruments over the course of its entire mission. It's hundreds of thousands of separate images and other data as well. All the solar telescopes. I mean, it's kind of amazing. It's too much. And the when the Vera Rubin Observatory comes online, like next year, it's going to be dumping petabytes of information just out onto the internet, just disgorging it. So yeah, absolutely. Start, especially if you're familiar with managing big database files, get in there and dig around and see what you can find. There are asteroids to discover, there are supernova to discover. There's all kinds of good stuff.
I still don't have an asteroid named after me, and I'm starting to become bitter. So if you find an asteroid,
name one after Pamela.
He has one.
Yeah, there was someone discovered a bunch and named them after a bunch of science communicators recently.
Yeah.
Arjun asks, could we tell a lot about a planet by looking at the day-night terminator, like mountains, oceans, pollution, etc.?
There's some work trying to figure that out using the moon, but it's not something we can do yet with exoplanets. If we can figure out how to do it with moons within our solar system, I think that would be considered a win right now.
Yeah, so we could. It's kind of amazing that if you got the next generation of telescopes, like the European Extremely Large Telescope or bigger, that you could aim at one of these worlds and then you could watch as it goes into day and night, and then, as you said, maybe detect light pollution, but also start to resolve out the continents based on how the light changes from day to day to day. Over time, you can start to build up this numerical model of how much ocean coverage there probably is, things like that. But it will take really big telescopes to start figuring out if there's mountains, things like that. One idea that I've seen was essentially you could detect shadows at different times of the year. And so if you're able to observe a planet with a big telescope, you could detect the way the mountains cause shadows at different times of the day over time and get a sense of whether it's mountainous or whether it's flat.
And one of the things I don't know that I now want to find someone to ask, because someone else must have calculated this. If Mars, with its giant volcanoes, transited the Earth, would we see a variation in the amount, not transited the Earth, transited the Sun, would we see a variation that was significant enough in the amount of light that it obscured that we'd be able to tell there's a not quite round object rotating? I'm pretty sure it's way too small a difference, but it's still something cool.
Yeah. It's like a triangle, a natural triangle.
Yeah.
With its great big volcanoes on the surface. Yeah, that's a really cool idea. Oh, there you go. Scott Manley got an asteroid named after him.
Yes,
you're not bitter. What would you be willing to trade? I'll trade you. How about a Wikipedia page?
Fair.
Let's see. Arjun is asking, they didn't even name a rock on Bennu after you? Oh, that's too bad. That would be good.
So the reason this one hits me hard is back in 2009 during the International Year of Astronomy, there was a whole bunch of us together just hanging out in a pub. And everyone around me got into my asteroid number is lower than your asteroid number competition.
Oh.
And I was the only one at the table without an asteroid. And it made me sad. And I've continued to be sad since 2009. And that my asteroid number is lower than yours conversation.
Yeah, I think, because you're such a skilled computer programmer, once Vera Rubin comes online, go get your own asteroid.
You can't name one after yourself. That's like one of those things you're not supposed to do.
Okay. So you need to do some kind of partnership with somebody else where you find one and name it after them and they find one and name it after you.
I think there's murder movies written that
Yeah,
way.
exactly. Crisscross. ABQ Halsey's asking, what exactly is in those little air conditioners that astronauts carry to the launch pad? Do you know what I'm talking about?
Oh,
I know
those
what
are
they're talking about.
they're rebreathers.
Yes.
So their spacesuits are airtight because they're spacesuits. And so those packs that they're carrying are first of all keeping them powered up so that they stay cooled and all that sort of stuff, and are also pumping air in.
Right.
Breathing.
Yeah.
You need to.
Yeah, and then they connect them up to the spaceship, I think, and then they're able to continue breathing while they're inside the ship.
Yeah, they plug into their chairs, I think.
But the design of those suits, I forget the name of them. The orange suits that they wore for the space shuttle.
Yeah.
Those were a redesign that came after the Challenger disaster.
Right, because they were in jumpsuits prior to that.
Yes, yeah. And the Challenger investigation determined that after the problem, after the boosters exploded, the actual orbiter, they were alive. The orbiter traveled through the air for minutes and crashed into the Atlantic Ocean, and the astronauts were probably alive for the entire journey. And so after that, they made changes. So they added a way to escape off of the space shuttle with like a big long pole that the astronauts could go and
still wouldn't have worked for Challenge.
Maybe, yeah, who knows? But they would have climbed out onto this pole and then jumped free. And they also would have much better spacesuits on board as well.
Yeah.
So, yeah.
Yeah.
We need more questions.
Cosmic Star Dream asks, could we conceivably make our own crater by dropping something big from orbit, then name the crater after us? I'm pretty sure the United Nations would have words with you.
But I mean, it has happened.
Don't do it.
Yeah, but it has happened on the moon and on various asteroids.
Yeah, where we've purposefully impacted things, but we haven't done this to our planet, except with like Skylab, and then the chunks weren't that big and the craters were really small.
Right. So
we're sorry, Australia.
Yeah. That's funny. Hal McKinney asks, when can us Astronomy castaways get to go on another cruise? Who knows?
I don't know about a cruise. What I'm hoping is next summer maybe to do something at there's a castle in Ohio, because why not? But it has super dark skies, it's off the grid, and it has amazing tables for gaming, and we may do something out there.
That's really cool. Yeah, we did a bunch of those. We did a bunch of those adventures with Paul Sutter and his team.
Sutter.
Yeah, and then we did
Astro Tours.
The Astro Tours, and we did the cruise to the end of the world, and that was fun. I don't think
we lose money when we do this.
Yeah. The problem is that it's just not a money making thing. So I think the only thing that makes kind of sense is that we agree to meet somewhere and not try to have it be organized. Like some place that has facilities, like, hey, we'll all meet at Yellowstone on March.
And that's what I'm talking about with Ravenwood Castle, basically.
Yeah.
And so like the Eclipse didn't lose money because we basically figured out how much it was going to cost and said, okay, your ticket price is the cost divided up by how many of us there are.
Yeah.
But other than that, like, it was thousands of dollars to go on that cruise.
Yeah. And it's just, I don't know. It's really hard to organize those kinds of events and have them not be an enormous amount of work for no real benefit.
Yeah.
And,
we all really want to just go hang out at Yellowstone with y'all at some point.
Mm-hmm. Yeah.
And I'm thinking the castle next summer, because Castle in Ohio with dark skies, everyone bring their own telescope would be cool.
Yeah, I've been thinking about things like even like the Iceland trip was super fun, or going to Costa Rica. And there are tour packages that do that. And I think it just makes sense to say, hey, everybody, we're going to go on this trip on this date. Yeah. Here's the number to call if you want to be on the same trip with us, and we'll hang out. But apart from that, I just it's too much work to organize these things. It was like even the eclipse trip was so much work. And
Nancy Graziano and Susie Murph worked their butts off to make that happen. Yeah.
And so it just, I mean, if we had much larger communities, maybe that's a thing that we would want to do more, but it's just, for the size of our community, we just don't, we're just not popular enough.
Well, and we have a lot of introverts who really just don't want to leave their house. Yeah. I feel that.
Yeah, exactly. Arjun asks, when will insurance start for space tourists? Is it when the price gets cheaper?
So I don't know if you saw, but the FAA has approved Virgin Galactic to start doing commercial flights.
Yeah.
That came out, I think, today.
It's a race between Blue Origin and Virgin Galactic.
Yeah. And so with that approval, we don't know if it's months or a year away, but it's imminent. And So here's the question. Are we going to have Virgin Galactic space tourists or JWST launching first?
Right. Both are similarly delayed, I think, at this point.
Yes.
Yeah, that's funny.
So both have been like 2 years away since 2007. So, it's finally, I feel like we're going to start getting our rocket cars.
Yeah, but I guess sort of part of that question, I think, is that Arjun was getting at was like, right now we don't know if it's safe or insanely dangerous to get on board a New Shepard and fly to space. None have crashed. They've all worked perfectly. But will they always work perfectly? I mean, we know that you had a 1 in 60 chance of losing your life in a space shuttle. Yeah. So is it going to be those kinds of odds?
So I mean, it's a whole lot better than it was when we were kids, where it seemed like one massive commercial airplane at least had a crash of some sort every year. Mm-hmm. Now it's much better than that, and we can go several years without incidents. Yeah. But it's still not perfect. And so the question comes, are we going to tolerate the same safety issues that airplanes had in the 80s with space industry today? And I think where it is being done strictly for pleasure as a tourist endeavor and not as a way of getting mail, commercial goods, and sales reps cross country, we're going to have a lower safety. We're going to have a higher safety need and a lower tolerance for failure. Right. And I don't know. I know the companies are going to make you sign all sorts of I'm not responsible releases. Yeah. Yeah. But can you get Allstate Travelers insurance to go to low Earth orbit? I don't know. Yeah, good question. All right. Well, we've reached the end of our show. Just a reminder, this is the penultimate Astronomy Cast. Yes. Next week is our last episode before we go on hiatus. So just don't forget to join the weekly Space Hangout crew and various other communities. What have you guys got going on in your side of the world in the next couple of days? So we are putting together our final guest list for CosmoQuestacon, which is July 16th through 18th. And go buy a ticket, folks. We're going to have a main stage, a backstage. We have folks that are going to be doing readings and art. It's a celebration of 80s space, where Voyager 2, 40 years ago this year, encountered Saturn. And the first space shuttle launch was 40 years ago this year. So I'm going to let my hair give in to its desire to be 80s hair. And we're going to do big hair and rock the blue eyeshadow and talk all the science of our childhood. So please, CosmoQuestacon, check it out, cosmoquest.org.
Awesome. All right. Thank you, everybody, for joining us today. Thanks to our moderators. Special thanks, as always, to Nancy Graziano for keeping us organized in advance and during the show itself. We couldn't do this without you. Thanks, everyone, watching on YouTube and on Twitch. And we will see all of you next week. Thanks, everyone.
Goodbye.